to under 25% leakage.
Because right now it's 60, right?
It's in that neighborhood. You know, there's a, in the report you can see how much water we're sending out. Now, April, May, June through October are tough months because there's a lot of irrigation going on, so we can't actually study and verify what kind of water's coming back, but we do see that we have a tremendous amount of water loss based on January, February, and March. So our current status at this point is there's no action taken.
And this is through a pipe system that's how many years old?
Well, it varies, but it goes back to 1972. And I think one of the biggest issues that we have is out in Chalet 2, where they put in all of Chalet 2 for $1.5 million. And our biggest issue when we make repairs is that the installation was not done well. And so rocks typically were left in the trench, the new piping was put in right over the rocks. Over time, what that causes is small leaks, big leaks, but mini leaks. And then another issue that we began to understand more thoroughly is that all of the valves are a slip-on valve. The valve that we use now is a mechanically restrained valve that has a gasket that's bolted on, and so that prevents leakage and it prevents the infrastructure from shifting. Now these older valves, and there is an example of it in the shop at lunch if you want to take a look at what the vast majority of the system is comprised of. They are just a slip fitting, and so there is no restraint. And I suspect that the vast majority of the leakage that we are experiencing here is due to those valves and fittings not being mechanically restrained. It's called background leakage. It's extremely difficult, if not impossible, to locate with the technology that is available. And so how we identify our leaks mostly is through customers. We do rounds once a month at every residence, and so we have an opportunity to do an inspection ourselves. But that's typically where we think that most of the water is leaking. And if you think about it, you have 65 miles of distribution system. And so if you're leaking 1.25 gallons per mile, that accounts for the water loss. That's not a lot of water for a mile of pipe. And so the problem is significant. In my opinion, the next large step that should be taken is for an engineering firm to produce a hydraulic model, and then we can try to reduce our pressure in certain areas, and that would probably be our wisest investment of funds, is to reduce pressure. And then once the dust settles on various other projects and all of the critical lift stations and the telemetry items have been worked out, then we can start working methodically on the system from one end where we have the most problems. That Chalet 2 up here is on the right side of the map here, and what they did out here that they didn't do in Chalet 1 is that they installed all of the corporation stops. And so there's a line installed for every lot. And we find a lot of leakage right there. So that what will happen is that line's never been used since it was installed, and then there'll be a little crack in the pipe. And so it typically, that's where the leaking is. And all we could do is go through and dig them all up and shut them off. And that's really the next step. And while you're at it, you can replace valves. Each of those valves, as I stated, the 8-inch gate valve is $1,000. We have 577 gate valves. There's probably at least 20 that need to be replaced immediately. That does not include your asphalt paving, which can cost anywhere from $5,000 on up, depending on how much disruption has taken place on the asphalt. Go
And
ahead.
what gives you an indication that they need, that those 20, what about them, are they worn out?
An
Are they-
observation, an exercising program that we did last year, and we have a form and a GPS handheld unit that identifies each valve, and then it tells you what was done to the valve, what was observed. So when you have a valve that's leaking water, you can see the water inside the valve box. Those are probably the highest priority, and one of the main reasons that you would never want to not have a chlorine residual, because there is the distinct possibility that you can draw in little bits of that water from those gate valves, especially if there's a
Say
pressure
that
drop.
again.
So if you have a pressure drop inside your system and you have a leaky gate valve, and so that gate valve is leaking water, and it's got the ground saturated around it. If you get a pressure drop, it can pull water back in.
Well, it can
Contaminate the water.
It can pull more than water back in, it can pull
Contaminate.
contamination.
Exactly.
In fact, that's what happened in Alamosa, I think.
Bacteria at least.
Yeah.
So more times than not, the valves are what is leaking than the pipes themselves. Sometimes you run into the pipes.
It's the fittings, right, Steve?
Well, for the overall water loss, the unaccounted for water, I think that is more than likely coming from the valves.
Yeah.
The leaks seem to be mostly pipe, the big leaks. It's a piece of pipe that bursts.
Right.
And if we're lucky, the water comes to the surface. If we're unlucky,
Yeah, you don't know.
Yeah, because
we don't know
Well,
what.
We're on sand and
you
gravel.
assume it goes back to the aquifer, right?
It does.
But
That's
you
the
don't-
good
It does.
news.
You don't really have a percentage of how much goes back, or
That's the
Well,
only good news.
I mean, we
They
do
don't
have a
like
pretty
that.
good
They say
idea
so
because
what?
it's not on the ground. So the most of the water that we're leaking is more than likely going back into the ground. Yes.
I think
Are the
Max's-
valves in line, or are they the T's to the residents, or is it both?
The gate valves are represented by these white pins on the map here.
I mean, like the 20, are they the in-line valves, or the?
No, they're just dispersed throughout
Oh.
the district.
Okay.
Yeah, it's just
So
a
it's the
matter of
construction,
maintenance.
not the installation? I mean, the way they were built rather than how they were installed, or?
It's a good question. I don't know. Some of it may be use. It may be pressure related.
So let me just get one thing straight real quick. The pipes that you have in the ground now are really not the problem with the lead and copper. It's
That's correct.
It's people's houses.
That's right.
So, and then when you replace a pipe that bursts, you're just replacing it with a new pipe, and
A
it's,
PVC pipe, yeah.
and it's also obviously not gonna have any problems. Okay, I just wanted to know, so it's really within people's homes.
That's right.
Is the lead and.
And we're responsible, as you said earlier, for the water coming out the tap. So
Right.
Yeah, the district has to ensure that it's safe to your tap.
As far as the leak goes, is there any problem with the wastewater side, the return flow? And that's not under pressure, so.
Based on Brad Simon's opinion and review of our system, he doesn't think that we're losing water out of the collection system. I'd have to agree with him. It doesn't mean that the collection system does not require a large amount of maintenance and inspection, but we don't think we're suffering from a large amount of infiltration from spring runoff, or that we're leaking wastewater into the ground.
Is there another question over here, Dean? I'll ponder it for a bit.
I'm gonna ask a lot of questions.
Good.
The-
But we will leave at 5 o'clock.
Well, that's my last one for this, Matt. But the potash that you were talking about,
Right.
and that's an all natural thing. It's ash or
Yeah, it's, it's a product that is, it's industrially, whatever, manufactured
Right.
in a controlled environment. But where potash is derived from, I honestly don't know.
and that's supposed to help with the acidity.
Yes.
And that could help a little bit, but it could take months.
No, that we expect to have sooner.
Yeah.
Because we've applied for design review on that to the state. So we've hired an engineer to design a system that would implement that into the water distribution system. He's sent that design on to the health department for their review. They have to approve any change to our drinking water plan. So as soon as they approve it, then we can install that capital infrastructure to allow that dosing to
So it would
happen.
help with the pH, it
Yeah.
helps the acidity.
And
Right.
and then stops the leachage of the leaching of the copper in there.
Right.
But then the chlorine, you would still have to add chlorine, but
you
not
would.
as much, or?
I really don't know how it's gonna react.
No, the chlorine will not be affected one way or the other. We have the chlorine as low as we can get it
By
at
law.
this point.
Or law?
Well, you can never have less than 0.2 at your entry point.
Milligrams per liter.
And so we dose at 0.3. That gives us a little buffer.
Mhm.
And we feel that that is a reasonable target for maintaining a safe residual throughout the entire system. So
You have to have
that's
some
where we're
trace
at.
amount at the very end. Otherwise, if it's all consumed before it gets to the end, then it has there are untreated areas. So you have to have some residual at the very end of the system. 0.2, as Stephen said, is the minimum that the state requires. You have to do at least 0.2. And then to ensure that you have actual chlorine working throughout the system, you have to have something left at the very end of the system to ensure that it's not all consumed.
And that level is 0.3.
Right.
So
That's
one-
what
one
works in
tenth
this
more
system.
of a milligram is.
Now,
what,
just to clarify though, the state maximum, we're talking about 0.3 right now milligrams per liter. The state maximum, and Stephen,
It's 4 milligrams per liter.
4 milligrams per
Allowable
liter.
by the state.
So, that's magnitudes greater than what we're putting in
You guys
That's
ever-
all at the source, those numbers that you're.
at the source,
Right.
yes.
So
that's
how do
it.
you account for the flow through the system? Because like at my house, sometimes the chlorine level was tested at 0.34.
Well, we've gradually been bringing it down.
Right.
And so when we did test at your house, it was up at 0.34. That was our target number. As a response to customer concerns, we've tried to drop it down as low as we possibly can.
So you had
So-
it at 4.
No,
No.
we had it at 0.34.
Oh,
Yeah.
0.34. So it's still well under 1.
And
And
So
so
no
when
matter
we
what-
tested at your house, we were dosing at a higher rate.
But I had it tested separately this winter and it was still at 0.34. So is there some way that you're flushing the system or
No,
how are you getting it through
No,
the
it
system?
couldn't be
with
higher.
Volume of water?
it couldn't be higher. So,
Well, it did
um,
test higher.
well, how did you test it?
Well, I had somebody else come up and it was the same kind of substance as what Mark had used.
Okay.
So,
But also, you're quite close to the source.
no,
So,
I'm not.
where's your house?
I'm almost,
No,
I'm in the outer ring.
Are you? I thought you were in Chalet 1.
I am in Chalet 1.
Well, it can't be more than what we're dosing. It doesn't accumulate in the system.
Well, I'm just
So
wondering if
at
it's,
that point,
because
it
of the way
must have
that.
been at 0.34 at the source,
Okay,
and there's just no way that it's going to increase out in the system.
right.
And
Because I'm just
so,
wondering, because all these things are affected, by the volume of water that's going through, and I noticed that January there's a less volume, but also, how the system itself is designed and because it has, some gravity flow.
hi, Dean. How you doing?
good.
Coconut is amazing stuff.
Yeah.
That's just all I have to say about that. During the Vietnam War, they use coconut water in place of plasma. It's
Yeah.
like really tuned in for being like with humans. Like coconut fiber is the bomb. That's all I know.
I agree with that. So it's always higher, your readings will always be higher closer to the treatment source.
Right. Yeah, it's gonna get consumed as it goes through the system. That is, it's going to do it, it's gonna kill things in the process.
So at the very end of this, it's got to be 0.2.
Yeah.
Dean has a question.